Welcome to the Diamond Element series by Mastel. In this series, we hope to assist our clients in making more informed scalpel purchases. We aim to promote the understanding of blade design in relation to wound architecture and to encourage customers to purchase lances in place of spears. This presentation covers Element 1, Piercing Characteristics. We will begin by using some basic geometry in order to contrast the effectiveness of three common tip angles, 90 degrees, 60 degrees, and the new Mastel Perfect port, which is 55 degrees. Later, we will demonstrate how different blade configurations can induce corneal stress. Here we are showing a 60-degree lance tip with symmetric edges and facets. Please note, we are not referring to the side edges or margins. Now imagine a force unit vector directed upward. If we were to have a perfect blade, the force at the tip would concentrate at an infinitesimally small point. However, in reality, this is not the case. Due to blade geometry, part of the original force is diverted laterally into what we call the lateral wake force. So due to blade geometry, we are left with two resultant vectors. One in the same direction as the original force, the piercing force, and one directed laterally, the lateral wake force. Dividing the piercing force by the lateral wake force will give you the piercing force effectiveness. We can now use the piercing force effectiveness to compare the spear, lance, and perfect port mathematically. As you can already see, reducing the lateral wake force will achieve a superior piercing force effectiveness. Here we are looking at three different piercing tips: a spear, a lance, and the Mastel Perfect port. As you can see, by decreasing the tip angle, the piercing force effectiveness increases. Thereby, a lance is 73% better than a spear, and the perfect port is 92% better than a spear. Let's take a brief look at how corneal anatomy affects piercing. The cornea, as you are familiar with, is a layered structure covering a liquid chamber. When piercing the cornea, you apply compressive stress to the tough membrane's outer surfaces, which act as an elastic membrane. Once your scalpel has advanced to the point of Decime's membrane, you switch from compressing a material with support to pushing against only a fluid. By using a spear, a dull blade, or both, you inadvertently cause higher resistance to piercing and are essentially causing tension on Decime's. Worst case scenario, this can tear Decime's away from the other layers of the cornea. When piercing an elastic material, such as Decime's, deflection occurs before penetration. This deflection can be modeled as a parabola to determine the total distance over which the blade's force is distributed. Here we compare the distances over which the force is distributed for a 90-degree spear, and a 60-degree lance. Upon calculation, you will find that the lance pierces only half of the tissue that a spear does. You will also find that the force is 86% more concentrated in a lance. This means that using a lance halves the piercing-induced stress on the corneal structure. In conclusion, we have found that smaller tip angles have greater piercing force effectiveness and cause less corneal stress by delivering a more concentrated force.